Today we are going to discuss basis part testing. See, basis part testing is a white box testing method. It is used to design the test cases. In basis part testing method, control flow graph is designed to find a set of linearly independent paths of execution. Cyclomatic complexity is used to find the number of independent paths of execution, and then test cases are generated for every possible path of execution. Okay. In basis part testing process, 4 steps are there. First one is draw the control flow graph of the source code. Then calculate the cyclomatic complexity of flow graph. Then make the set of possible path of execution, and then create the test case for every path. Okay, now we have an example. This is a control flow graph. So we have designed this control flow graph for the program. Then second step is determine the cyclomatic complexity of the resultant flow graph. Okay, so we know that there are 3 ways to compute the cyclomatic complexity: by using the number of regions, by using the number of edges and nodes, and by using the number of predicate nodes. So in this flow graph there are total 4 bounded regions are there, for that is R1, R2, R3 and R4. Okay, so cyclomatic complexity for the flow graph G is equal to number of regions bounded, that is 4. That means our cyclomatic complexity is 4. Then second, it is computed by using the formula E minus n plus 2, where E is number of edges, n is number of nodes. The number of nodes are total 9 nodes are there in the graph, and total 11 edges are there. So that's why complexity is 11 minus 9 plus 2 is equal to 4. Third way to compute the complex cyclomatic complexity is P plus 1. P is number of predicate nodes. Predicate nodes means the nodes which have the condition and the node which create 2 different nodes. Here predicate node is 2, 3 and 1. Okay, total 3 predicate nodes are there. So that's why the complexity is 3 plus 1, 4. That means our cyclomatic complexity is 4. The third step is determine the set of linearly independent paths. We know that the cyclomatic complexity is equal to number of linearly independent paths. Means there are total 4 independent paths in the flow graph. So we have to find out these paths. See, the first path is 1 and then 9. So 1 to 9 is the first path. Second, 1, 2, 3, 5, 7, 8, then 1 and 9. Third path is 1, 2, 3, 6, 7, 8, then 1, then 9. And fourth path is 1, 2, 4, 8, then 1 and 9. So there are total 4 linearly independent paths. So that's why the cyclomatic complexity is 4. So the last step is create the test case for every possible path of execution. That means we have to create the test case, 4 test case, each test case for every path in this flow graph. This is all about basis part testing.